Thank you for coming, and so I'm going to talk about chapter 2.3 and 2.4 related to the quiz tomorrow. So for chapter, I think it's 2.3, right? Yeah, it's 2.2. So for quiz tomorrow, we will cover separate equations and linear equations. So for 2.2 is separate equations, and ODE can be separated only it meets this formula. So once you get some formula look like this, so gx is a function of x and hy is a function of y, and you organize all the x on one side and all the y on the other side. That you separate them, and then you take integral of both sides. So for this one, you need to transfer this as, so you put hy and dy on one side. So that is 1 over hy dy equals gx dx, and you take integral of both sides and you got the constant. So that is the basic method to solve a separable equations. So let's see some examples. Okay, so for this one, it's a very easy one. So the first step is we observe this equation and try to find whether this one is, so whether this one is separable or not. So we can put it, look at this.
Okay, secure about.
So in this way, we can see that dy over dx is the function of equals the function of y times the function of x. But here the function of x, which is, so gx here is just 1, and hy is negative 4y, or you can see that gx is negative 4 and hy is y. So we put all the y on one side and all the x on the other side. So you move y to here, that is 1 over y equals negative 4 x. And then we take integral on both sides. And we get, so the integral of y over 1 over y is ln y, and here is negative 4 times x plus c. And then you put e here, so you can get the function of y, which equals, so this is e to the c times e to the negative 4x. So this is our constant, and here is the absolute value of y. We can put the negative side and positive side to this c. So we can just write c1 here, and we get rid of these things. So that's y equals c1 times e to the negative 4x. So that is the final answer for this one. So, and let's see something. Okay, for this one, so this one is also separate because you can, here we can separate this whole thing into the the mod gx times hy, right? So at this time our hy is equal to 1 over y, this part, and our gx is this whole thing. So that is h over 1 is h squared, and so this is equal to y over dx. And then we put all the y on the left side. That is y times dy equals, that is x over 1 plus here you have dx. And we take the integral on both sides. Let's see. Here we simply get 1 over 2 y squared. And for this one, we notice that for the numerator, here is x squared, but we only have dx here. And we have x in the denominator. So we can, because dx squared is equal to 2x dx, so we can combine x and dx, so we get, so for this part here, we can get 1 over 2, because we have 2 here, we need to cancel this 2, right? And so that is dx squared. So we grab 1 over 2 outside, and we get 1 over 1 plus x squared dx squared. So right now you can assume that x squared is u. So this is u. So this whole thing will become 1 over 2, the integral of 1 plus u du. So the integral of this whole thing is 1 over 2, and we can put it here, so that is ln 1 plus u. And notice that u here is our x squared, so it's 1 over 2 ln 1 plus x squared here. So we got 1 over 2 y squared equals 1 over 2 ln 1 plus x squared plus c. And we can cancel 1 over 2 on both sides. And finally, we got this. Do you have any questions so far?
Yeah, so in any case, can you just multiply dx to the other side? You can multiply dy and dx.
You mean the 6?
Yeah.
Yeah, because here is just dy over dx, so you can separate these two. That's how we solve the separable ODE. So y prime is equal to this 6, and but you can like you time dx on both sides and cancel dx on the left side, and you got dx on the right side. So
okay.
it's okay if we do that. So any other questions? You okay? And let's do one more. I think this one is from the website. So, do you want to try to do it yourself and let's solve it? So the first step is how can we separate y and x? So we organize all the y on one side and organize all the x on the other side. So how to do that? So the first step.
So do you have to distribute the right side?
Mm-hmm.
And then I guess you could divide by y and multiply by dy on both sides.
So let's see, we have ln x and dx on the left side, and we keep it here. And here, and then you said put y and dy right on the left side. So when we grab y on the left side is 1 over y, and then we times dy here. So what about this part? What should we do with this part?
You can expand it, right?
Yeah, so we can write it as this. So that is a function of x and a multiply function of y, right?
Yeah.
So because all the x is on this side, so we multiply x squared on both sides to cancel the x squared on that side. So here, that is x squared here and x, so we get rid of this part and we keep that part on the right side. So that is And okay, and the second step is we take the integral on both sides, right? And for this part, since this part seems easy, then this part is contains the log x and x squared, so we do this part first. So and we can, because we really don't know this whole thing, because there are multiple 1 over y times 1 plus 1 y plus 1 squared, so we don't know the integral of that. So we want to simplify that, and so the way to do that is we expand y plus 1 squared to see whether we can find a way to solve it. So here we got 1 over y, and if we expand y plus 1 squared, we have y squared plus 1 plus 2y and dy. And we get, so if we multiply 1 over y inside here, we get y plus, so 1 over y plus 2 dy. So this seems much more simple than that one. So we can separate the integral of y dy plus the integral of 1 over y dy plus 2 dy. So this part, the integral of y dy is just 1 over 2y squared, and this part is log y, right? And here is just 2y. So we got these things y, and now we need to solve the left part. So these things. So we really don't know what is the integral of log x. So there's a way to do it. So cause we, so do you know this things? So we use this method to solve the integral of this part. So, do you have any questions on this?
No, it's all good.
Okay. So, and we set u equals log x, and so du dx is the derivative of log x, so which is x over 1 over x, right? And we set dv dx equals to x squared. So v is the integral of x squared, which is 1 over 3 x cubed. And then these whole things, log x times x squared dx is equal to here u times v minus integral of v du. So our u here is log x times v here is 1 over 3 x cubed, and minus the integral of v, which is 1 over 3 x squared, and du. So du here is 1 over x dx. And so we already got this part, and the only thing we need to do is to solve this whole things. So this thing is equal to, we grab the 1 over 3 out, and x cubed times 1 over x is just the x squared dx. So it's 1 over 3 times 1 over 3x cubed and plus c. So it's 1 over 9 x cubed plus. So the whole thing is here log x 1 over 3 log x times x cubed minus 1 over 9 x squared plus c. So the whole equation should be this whole things equals to these things. So, is any questions?
No.
Okay. So let's see this one. Okay, so this one's let's so the first style of this one is oh my god how to solve this one, but so if we use the group factor and this one can be much easier. So the way to solve it is we take the denominator and the numerator. So we take the group factor from numerator and denominator. So for this, for the denominator, for the xy plus 4x, we have the group factor of x. And we graph out x, and we only left y plus 4 here, right? And minus, we take the denominator here, and we get y plus 4 here. And for the numerator, the same way, we got x, y minus 3, and we take the 6 out, we got y minus 3 inside. And here we have this one, this one, this one, this one, the group factor, and we just keep doing it as x minus 1 and y plus 4 here, and we got x plus 6, y minus 3 here. So notice that the question is asking what is x plus 6 over y plus 4 to the order of 7. And we can notice that we have the x plus 6 here, and we have the y plus 4 here. And so after we group factoring this, and we can separate this, because here is our gx, and here is our hy. So use separable methods, we get the y plus 4 and over y minus 3 on the left side. We can have y minus 3 over y plus 4 dy, and left on the right is x minus 1, x plus 6, and we multiply dx on both sides. We have dx at here. We take the integral on both sides. So at here, the numerator is y plus 4, but the denominator is y minus 3. We can play some trick. We can make the denominator to y plus 4, but we have minus 3 here, so we need to minus 7. So the denominator is equal, and we left the y plus 4 on the numerator. Y equals, so the same thing here, we put plus 6 and we minus 7. We got these things. So the reason I make the part of the numerator equal to part of the denominator equal to the numerator is because for here I can separate these two as this. So you got the integral of, so y plus 4 over y plus 4 is just 1 minus 7 over y plus 4 dy. Here we have y minus 7 over x plus 6 dx. So now the integral of both sides is easier than these things, and we have, so here is, we got the integral from 1 dy is just y, and we minus, so that is, we get out, we grab the 7 in front of the integral and left here here is y plus 4, so we have ln y plus 4 here. And this is equal to x. Here you have minus 7 and ln x plus 6. So plus c, but it's here we can just ignore c right here because it's, I don't know if there's a c, we cannot get that one. Maybe, yeah, maybe we can. Okay, let's plus c here. And but here the question is asking x plus 6 over y plus 4. So we need to keep doing until we get these things, and we move x here, so that is y minus x, and maybe you can write plus c1. So c1 is negative c, and here we got 7 ln x plus 6 minus 7 ln plus I think it should be, oh, here is the negative sign, sorry, and the plus 7 ln y plus 4, and so let's look at this part. So for that part, we know that ln x plus 6, so that is, if we get out of negative 7, we have ln x plus 6 minus ln y plus 4. And we know that if there's a minus sign here, we can get ln x plus 6 or y plus 4. So at this point, we got this equation as we wanted, right? And so this is equal to 1 minus x plus c1. So we multiply negative 1 over 7 on both sides. So here we have the negative sign. And then you put the e here, so you can get this whole thing. Oh wait, sorry. I'm so sorry. So here, here we have the 7 power here. So, and we have negative 7 here, and the negative sign here. We can put this 7 at here. So this just equal to x plus 6 and y plus 4 to the 7th equals to this whole thing. And we take the exponential sign here to get rid of this. So we only left these things. Is that
Wait, how did you get it to the 7th power?
Oh, these things? Because, so, let's say ln x squared is equal to 2 ln x, right? So that's why I can put the 7th power, because this is 7 multiple this whole thing, so I put the 7th power at here.
Okay.
So then we can solve these things. So the first step of this one is we try to use group factoring to get rid of this whole complicated things, and we use and then this can be separated, and then we use the method for separable equations, and we solve on both sides, and because we really need to do this whole things, and look at our equation here, we have y plus 4 and x plus 6, so that's, and you just keep multiplying it, and you can get this whole things. You have any questions for this? Okay, so that's all I want to talk about separable equation. So the key point to solve a separable equation is you need to separate the function of x and function of y on both sides and take integral of it. So that is a key point. So it shouldn't be hard on the quiz. and let's move to linear equation. Okay, so for linear equation, the ODE should meet the form like this. So a1x, a0x, and gx is only the function of x. So I think like you don't have any trouble to identify whether it is linear or non-linear, right? So it's but after we identify this equation is linear, and then the next step is we need to multiply the equation, and so the parameter in front of dy dx should be 1. So in order to solve it, this should always be 1. So if there is a function in front of dy dx, you need to multiply 1 over a1x and get rid of this parameter to get to modify this equation to meet this form. So px here is actually a0x or a1x, and the fx here is gx over a1x, because we want to get rid of this, right? And after you set your equation look like this, you need to find the integral factor ix. So ix equals to these things, which you need to remember it. And after you find ix, you multiply ix with dy dx with y, and you put them in a parameter. What is that called? And put them in prime, and multiply the integral factor with fx2. And if you want to get rid of this prime, you need to take integral on both sides. So that is a step you need to follow. Let's take some examples. Okay, so for this one, first we can easily to tell that this one cannot be separate. So it cannot use a separable method. So let's see whether it is linear. So here we have only the function of x and only the function of x, and so it is a linear equation. So we can use the linear equation method to solve this ODE. Okay, so the first step is we need to get rid of this parameter to set it to 1. So we divide x on both sides. So the first part is simply dy dx, and here is 4 over x dy, and here we got x squared minus 1, right? And at this point, here is our px, here is our fx. So after we finish the first step, the second step is to find the integral factor. Ix equals e to the integral of px dx, and here we have px is equal to 4 over x dx, which equals to e to the 4 ln x, and we can simply put and then we move the 4 to here, that is x to the 4th, and we have x to the 4th here. So the integral factor is x to the 4th, and next we need to multiply the integral factor with our y and put it in a prime equals fx, which is x squared minus 1 times the integral factor is these things, and we put it inside, and we get x to the 6 minus x to the 4th. And after that, we want to get y, so we take integral on both sides. So here, these things has cancelled with this prime, and we got the integral factor here is x to the 4th. And times y, here equals 1 over 7, the integral of x to to the 6 is 1 over 7, x to the 7th minus here you have 1 over 5, x to the 5, and you plus c. And so right now we get the equation of y and x, and we multiply 1 over x to the 4th on both sides to get rid of these things. So we can finally get our y equals to 1 over 7. And here we have x to the 3rd minus 1 over 5 x and plus. So here is c over x to the 4th. So that is your final equation. So you have any questions for this one? Okay. So once you follow the steps to solve the linear equation, and the problem should be fine. And let's move to the next example. So for this one, first, also this one is non-separable equation. So let's see whether it is a linear one. So here is a function of x, and here also only function of x. So this one is a linear equation, and we can use this the way to solve a linear, the methods to solve a linear equation. So first step is still we need to set the parameter in front of dy dx to 1, right? So it's just the same. And here you have 4 over x squared minus y. Here you have x plus 2 squared and x squared minus 4. So because x squared minus 4 is x minus 2 multiplied with x plus 2. So we can make this one easier to cancel this x plus 2. So we only have x plus 2 on the denominator and x minus 2 on the numerator. So, and right now, this whole thing is our px, and this whole thing is our fx. And the next step, we need to find the integral factor. So just the same thing. Here we got, so px in this case is 4 over x squared minus 4, because x squared minus 4 is x minus 2 times x plus 2. And so for these things, we need to use partial, I think it's called partial factoring, to solve this. So we can assume that this one equals to a over x minus 2 plus b over x plus 2. So if we only look at this one, we get so x minus 2 times x plus 2, and on the top is a plus x plus a times x plus 2 plus b times x minus 2, which equals. So here we have ax plus 2a plus bx minus 2b. Because these two equations should be equal. So here, and if we have a plus bx plus 2a minus 2b. So for this one, we'll only have 4 on the top, but here we have a plus b times x plus 2a minus 2b. So we don't have any x on this side. So a plus b must be equal to 0. And here we have 2a minus 2b should equals to 4. So in this case, these two things are the same, right? So based on these two equations, we can solve for a and b. So here is a is 1 and b is -1, right? Yeah. And we replace a is 1 and we replace b here, that is -1. So we got these things is equal to this. So we replace this whole thing inside of this one, so we can take the integral of this. So it's 1 over x minus 2 minus 1 over x plus 2 dx. So if do you have any question about the partial factoring? So if we take integral of that, we got e to the, so for this part is log x minus 2 and minus log x plus 2. And this equals to e to the log x minus 2 over x plus 2. Which equals x plus minus 2 and over x plus 2. So this thing is our integral factor. And the last step we need to do is we use our integral factor times y, putting a prime equals our gx. So the gx is the fx is this 6, so that is x plus 2 and x minus 2 times the integral factor is x minus 2 over x plus 2. So this thing is just equal to 1. And when you take integral of both sides, we got x minus 2 x plus 2y is equal to x plus c, and you multiply x, you get this at here, so you can figure out your y. So have any questions to this one? No? Is that clear? Okay. So for this one, what I really want to let you know is like the partial factoring things here, and that's it. So the last one here is
piecewise defined.
what?
Piecewise defined.
Yeah. So this one is continuous one. So I think the point for this one is to find the initial value for the next, I think is for x greater than 1. So for this thing, we need to separate these to 2 because fx has a different value related to different regions. So when 0 is smaller than x, smaller than 1, so fx is equal to x, and we have dy dx plus 2xy, which is equal to x. And this is also linear, and we find the integral factor 2x dx, and we got e to the 2 log x, which is equal to x squared. And we solve this, multiply the integral factor with y, and and we take integral of this both sides. We got x squared plus y equals, so here is 1/4 x to the 4th plus c. So this is when x between 0 and 1, and we have one initial value for this equation. So that is when x equals to 0, y0 equals to 1. So in this case, we can figure out what is the constant. So y here is equal to 1/4 x squared plus c over x squared. And if we replace x to 0, we have 0 here. And here we have something wrong with it. Oh, sorry. So for here, it's not flowing. So here it's just e to the. Here it's just e to the integral of 2x dx is e to the x squared. So the integral factor is e to the x squared. And we put e to the x squared times y equals to gx here is x times e to the x squared. And we take integral both sides, we get e to the x squared y equals so go here. I'll put it here. So x e to the x squared dx is equal to, we combine x and dx, so we get e to the x squared, and here we have 1/2x squared, and we put 1/2 outside the integral. We have 1/2 e to the x squared dx squared, and we replace x squared to u. So we have 1/2 e to the u du, which equals 1/2 e to the u. Because u is equal to x squared, so we have 1/2 e to the x squared here. So we put it here, to the x squared plus c, and we divide e to the x squared on both sides, and we can get y equals to 1/2, because these two cancel each other, plus c over e to the x squared. So that is for the first part of the equation, and we put our initial condition in it to solve the constant. We got 1, 0 equals 1/2 plus c over e to the 0, which equals to 1/2 plus c equals 1. So our constant in this case is 1/2. So we have any questions so far? Okay. So for the next step, when x is greater than 1, we have our equations dy dx plus 2xy equals to 1, and the equal to 0. So in this case, you can either use separable or you can use linear to solve this one. And what I want to mention is that because we only got one initial value, that is when x equal to 0, but when x greater than 1, we can only get our initial value through this equation. So that is replace it. So here is 1/2. So the initial value for the second part of fx is when x equals to 1 and y is the initial value of that. So the initial value for the second part is when x equals to 1 because x starts from 1 here. Equals 1/2 plus, and we replace x to 1. So that is the initial value for the second part. And you solve this equation and you put in the initial value to solve the constant, and you solve the whole thing. So, and I think that is for separable equation and for linear equation. And hope this is the review for the quiz tomorrow. So for linear equation, the so generally to solve a linear equation, first it should be a linear equation. So once it's a linear equation, you set the parameter to 1 by dividing a1x on both sides, and you got this. You need to meet this equation form, and then try to find the integral factor and use this equation. That is the integral factor times your function equals the integral factor times your fx. And you take the integral on both sides, try to solve for y. So that is the basic method for linear. And for separate, you just need to separate both sides. So do you have any questions related to this two, or have any question about the homework? No?
Good.
So good luck for the quiz tomorrow. And you can ask me questions if you still confused about this two method.
Do you know if the partial fractions is going to be on the quiz? Are we going to be expected to do that? Like, were you doing the a plus b?
Well, I'm not quite sure, but you should know that because it's not that hard, right?
Yeah.
Do you have any question about partial fracturing, so I can say it again?
Alright, I guess maybe you could do one more.
Okay.
A quick example of just that. I don't have a specific question.
Excuse me. Do y'all have this room reserved?
No, but this room is for art, so I think it's valid. You mean reserve this room?
Yeah, because I think we got it reserved for 7 to 9
Okay.
on Mondays.
We get out of 7.
Oh, no,
Yeah.
that's okay. I just wanted to ask to make
Oh,
sure that I
okay.
messed something up. Thank you, though. Okay, I'll leave it alone.
Okay. I don't have examples right now, but let me try to. But I don't have it, but I can maybe I don't know whether this one works, but let's say we have x plus 3 and x minus 1, and here we have let's say 5 or something. I don't know whether it's a perfect number, but so the first step for partial fracturing is that you need to assume that this equation is equal to x plus 3 and something on top plus x x minus 1. So these two are multiply each other. So this one is equal to this one. And the way our goal is to find what is A and what is B. But this one is always equal to each other. So after we assume that's equal to this, we try to solve this part. So, and if we want to solve this part, we need to multiply. So x plus, in the numerator is x plus 3 times x minus 1, and on the top is a multiply x minus 1, and here plus b multiply x plus 3, right? So, and here we got ax minus a plus bx plus 3b on top, and here we have this on numerator. Because these two equations are equal, so we can see that the numerator is equal now. So the top of this should also be equal. So we need to set phi equals to the whole thing there. So if we group factoring, so the first part is this a plus b. So put these two together. So we get a plus b times x. Here you have minus a plus 3b. And because on the right, you don't have any x on the right, so the parameter in front of x should be equal to 0, right? So a plus b should be 0. And here you have a number, and here, because a and b are also number, so that is you set this whole part equal to 5. In this case, this part is 0 and this part is 5, then both sides is equal. So plus 3b is equal to 5. And you solve for a and b. And you put it back to here. In this case, b is equal to 4, and here is negative. And you replace a and b with the number you get. Here you have negative, and here you have 4 over 5. Then this is equal, and you can examine it by solving this again. So that is the basic idea of partial fraction. So if you have x here, it's the same. If we add an x here, and also here you have a and b. But at here you got x, so you have x here and you have x here. So a plus b, so the parameter in front of x should be 5, right? So a plus b should be 5 in this case, and you don't have any numbers at here. So this part you set it to 0 and you solve a and b and put it back. So it's always remember that both sides of the equation should be equal. So that help.
Yeah, actually helps a lot.
So I think I'll end it today.
Yep.
And then thank you for coming. Love you.